Hey everyone, hope you're doing well. In this video, we'll be starting this unit of electric fields, which is again something which is very important as with regards to your exam. And you might think that I say this every time, and I really shouldn't, because each and every topic is assessed more or less in each paper. Anyway, this is an important topic also in the sense that the ideas that we'll be learning in electric fields will also be used in another chapter called capacitance. So electric fields is a sort of prerequisite for that chapter. But again, electric fields as a new chapter is not going to be very difficult for us, because luckily we've already studied gravitational fields. So the idea of fields and then the other ideas of field strengths and potentials more or less remain the same. Although there are a few fundamental differences between electric and gravitational fields, the study of gravitational fields will simplify things a lot for us here. So again, let's just start off the same way that we did with gravitational fields, which is the idea of what really is an electric field. So if you remember gravitational fields, we defined in the we define those in the way that there is a region of space in which a force acts on a mass. But electric fields are somewhat different, because electric, as the word says, and you might also know this from AS, electric or anything electrical is related to charges. So when we talk about an electric field, this is again an area or a region. But this time when we're talking about an area or a region, this is with respect to, again, a force. So fields are always about some sort of a force. So this is the area or a region where a charge experiences a force. So this is in comparison to gravitational field, which was also an area or a region, but it differs fundamentally, because gravitational field says where a mass experiences a force, electric field is where a charge experiences a force, right? So where a charge experiences a force. Later on, when we'll be going towards magnetism, again a magnetic field would be again an area or a region, but it just depends, it just differs based off what is the type of particle which is causing it to experience a force. All sorts of fields are areas of force, right? The next idea, again pretty much the same way that we covered it in gravitational fields. The idea is that all charges have electrical fields associated with them. So the short form for this, I'm saying, have E fields associated with them, right? So all of the charges that we have are also going to have some electric fields around those charges. So I'm very certain that whenever you guys must have studied science at an earlier stage, you would have known this idea that charges are of two types. So you have charges which can be categorized as either positive charges, or you can have negative charges. So something that you can have, any object could either be positively charged or negatively charged. And we can look at this using an experiment, a pretty simple experiment. So the idea is that you can charge something by rubbing it, and the technical term for it is charging by friction. So let's say we have a rod that became negatively charged by rubbing it, and then near to that rod we bring in a negatively charged rod, pretty much like this one, and we bring in a positively charged rod. So the idea is that when we bring the negative charges together, the forces on both of these are repulsive in nature. So this is trying to push it back, and this one is trying to push this one away. But again, since this is the only one which is freely hanging, the effect is much more observable here. So we would observe this rod turning in that direction. So the idea here is that like charges, and by like I mean charges of the same type. So since we are talking here about both negative charges, the same analysis would also apply to both positive charges. So like charges repel each other. And similarly, if the other end of this rod is also negatively charged and we bring in a positively charged rod, both of these would try to attract each other. So both of these try to pull each other towards themselves, but since this is the one which is freely hanging, again the effect is much more observable here. So the rod rotates in this direction. So again, for this one, for this case, we can say that unlike charges, so charges that are not of the same type, right? So positive and negative is the only one that fits the bill here. So unlike charges attract, right? So like charges repel, unlike charges attract. So although this is not really necessary knowledge for your A-level exam, negative and positive charges come about by flow of electrons. So when we say that something is negatively charged, we are basically saying it has an excess of electrons, and similarly if you're talking about positive something which is positively charged, we say that it has a deficiency of electrons, right? So we talk about these charges in terms of either an excess or a deficiency of electrons. So again, going back further towards the concepts that we were talking about, now is the time to talk about the idea of an electric field line. So we've understood what a electric field is. We know the different types of charges that you can have and on which electric forces can be applied. So how would we then talk about an electric field line? And this is pretty similar to the gravitational field line in itself. So if you may remember, gravitational field lines talked about the direction of force acting on a mass. So one thing I can say for sure is this is also going to show the direction of force acting on a charged particle, right? But the idea is that in masses you only have a mass of a kind, whereas you have a charge of two kinds. So we just talked about this above, that you could have negative or positive charges. So when we are drawing electric field lines, what do we then talk about? Do we say that this is the direction of force acting on a positive charge or on a negative charge? So purely by convention, this is the direction of force acting on a positive charge, right? So how would the force act on a positive charge, right? So always remember this, that electric field lines are drawn with reference to a positive charge. So if we talk about a small positive charge like this, and this is also sometimes this idea of a positive charge is also sometimes called a test positive charge, just to say that how would that behave in a field of another charge. So if I then draw the field lines for a isolated charge, right, like this, so the way that the field lines are going to look like are pretty similar to the ones that we observed for the gravitational field lines. So for example, if I were to draw these lines, then they would look something like this, that for positive charges these are going to point outwards in directions like these, right? So you have these radial lines basically that are spreading out, right? So the idea is that these field lines are what we call radial field lines. So let me just write this. So these are a radial lines. Basically, you can remember these as radiating outwards, spreading in space, right? So that's how these field lines look like. Now, if you think about this as the direction of force acting on a positive charge, then this would seem to make a lot of sense to you. Because if we recall that idea as to how charges behave, So if this is a positive charge and then another positive charge, if that were to be placed in the field of this charge, that would repel, because like charges repel. So a charge placed like this would move away from this positive charge, right? Then the next thing you need to remember is that these field lines are radial, and in a while we'll also be talking about the spacing of these field lines, and again that shows the exact same thing that it used to show back when we were talking about these the gravitational field lines. So if we have a negative charge now, and you can also probably guess what the field lines would look like for this test negative charge. So if we just think along these ideas that we were discussing, a positive charge would be attracted to this negative charge, so that would be moving inwards towards this negatively charged particle, so that would point inwards. Like this. So all these field lines are pointing inwards. And again, as is the case here, both of these are still radial lines. So again, like this. But when drawing the field lines, you need to remember that for positive charges, they point outwards, and for negative charges, they point inward. And the way that you can remember this is pretty much by the definition of an electric field line. With reference to what do we draw these electric field lines? So again, the idea is the same. What I was talking about is this, that the relative spacing of the field lines here as well so these show the strength of the electric field, right? So the idea is the same, that the closer the field lines, the stronger is the electric field over there. So if we just scroll up back again, so we'll see that the electric field lines are closest at a smaller distance from the charge, and then they get further away the greater the distance is from the charge. So then the idea is that the electric field strength decreases with distance. And how that decreases with distance is something that we'll be talking about in the next couple of videos, right? So this is another idea. And again, this is nothing which is really new to us. We've all studied this. This is just in a slightly different context, but the concepts remain the same.